Okay. Hi guys, so today I'm going to be teaching you the difference between what a series circuit looks like and what a parallel circuit looks like. So right here, all I have is a battery pack. Each battery is about 1.5 volts. So 1.5 times 3 is about 4.5 volts. I have the negative end of the first battery connected to one end of one light bulb, which is connected in a straight line to the other light bulb. So now when I close this circuit, right now this is considered an open circuit. When I close it and touch the metal spring, remember this metal part, the positive end is connected to the spring, which is nice because I can just alligator clip this little spring right over here. Even if I just touch it, electrons are able to flow. That conventional current that we were talking about. So if I clip this and I hold it there, you clearly see that both bulbs light up. Do they light up at the same time? Yes, because current flows very, very fast, nearly the speed of light. So I'm going to keep this here and sort of explain to you why Ohm's law in series circuits works the way that it does. So Ohm's law says that V equals IR. And depending on whether your circuit is a series circuit or a parallel circuit, which is what I'll get to, depends on whether current stays the same or voltage stays the same, and the difference in how to calculate the total resistance of the circuit. So right now, like I said, I have two bulbs, and there's a single path for the electrons to flow. There's a single path. Remember, when we talk about electrons, they actually flow from negative to positive. We know that, but first we discovered conventional current and electric fields. So we always thought that the protons moved from positive to negative, which we still use today, even though we know in reality protons are not the thing that move in an atom that can cause electricity. So here's the positive end. We start at 4.5 volts at this point here. 4.5 volts, that amount of push provides the current for the electrons that are already in this wire. It just pushes them, it moves them, and then it flows through the first light bulb. So there's current going through the tip of the light bulb from this end into the filament, which provides the brightness, the light, and then if you touch it after a while, some voltage will drop and escape in the form of heat. Some of the pushing, some of the voltage gets lost at this point. In a series circuit, the current here is the same as the current here, which is the same as the current here and here. So the current in series does not change. The way that we mathematically represent that is saying this. In a series circuit, I total, the total current in the entire circuit, equals I at point 1. Let's call this point 1. Point 2. Point 3. So on and so forth. The current here, let's say if it's 0.5 amps, will equal 0.5 amps here, 0.5 amps here, 0.5 amps here. Series does not change the current because there's only one path for the electricity flow. So because only one path for electricity to flow. Okay, what about the voltage? I mentioned something called a voltage drop here. The light bulb provides a resistance, allowing voltage to escape in the form of heat, basically, in the form of light, which will create heat, which I'm not going to go into too much detail of that. But all you have to know is that in a series circuit, at points of resistance, voltage will drop such that you start at the top of the hill over here, right? You start high at 4.5 volts. It encounters the first light bulb, it drops a little bit. You encounter the second light bulb at the same exact current, and it drops back down to 0 so that there's 0 volts going into the end of the first negative battery. So just know that in just like that first animation for the first assignment I gave you guys, that did an excellent job of depicting a 3D animation of voltage. Imagine there's this force, this electromotive force, if we're being fancy, allows the potential energy to increase up to some point, up to some height here, right? It allows the positive charges to get pushed up, and just like a ball on a hill, the positive charges, even though it's really negative charges, the conventional current is allowed to flow and drop back down to zero by the time it makes it back to the negative end of the battery. And we'll, in a further video, in another video, we'll actually do some calculations with that and how to actually find that sort of thing in a circuit, how to actually quantify the amount of voltage that gets dropped by this light bulb and this light bulb, for example. But for now, in terms of voltage, the total voltage is going to equal the voltage at the first point plus the voltage at the second point plus V3 plus dot dot dot. What this means is that voltage needs to drop to zero by the time current returns to the battery. This is called Kirchhoff's voltage law. AKA, the total voltage, 4.5 volts, equals the amount of voltage that gets dropped at this resistor, this bulb, plus the voltage that gets dropped at this bulb. This plus this better equal the total voltage provided by the battery, because that's the total amount of electric potential energy that went into the circuit in the first place. And then another thing that I'll ask you to be calculating is the total resistance of the circuit that allows this voltage to drop in the first place. Like I said in the previous video, if these two bulbs were not here, and let's say we connected this wire to the end over here, we would create a short circuit and drain the batteries really fast because the voltage didn't have a chance to drop back down to zero, and the batteries are going to go crazy. So the total resistance of a circuit, if you have more than one object, right, in a series, is you just add up each resistor. And remember, the unit for resistance is ohms, capital Omega. It looks like a horseshoe. So let's say this light bulb had a value of 5 ohms. It provides 5 ohms of resistance for that voltage to drop. This bulb also provides 5 ohms. So the total resistance would be 5 ohms plus 5 ohms. There's no third bulb or third resistance providing the voltage drop. The total resistance would just be 10 ohms. 5 plus 5 is 10. So that is your series circuit.